Number 2. While following the directions on a treasure map, a pirate walks 45 meters north and then turns and walks 7.5 meters east. What what single straight line displacement could the pirate have taken to reach this treasure? And so you see that these types of problems, they have like these kind of like weird contrived scenarios, but they're all going to end up being you using triangle skills, right? That's what they all end up being. So what do we actually have here? We have 45 meters north and then turns and walks 7.5 meters east. So what is the straight line displacement? Right, so we're looking for the value of the hypotenuse for this triangle that we've made here. Now, you guys know the Pythagorean theorem. A squared plus b squared is equal to c squared. Well, if we kind of substitute this in for physicsy type things, we're going to have the change in the x position squared plus the change in the y position squared, and that is going to equal the displacement squared. So this is something that we're going to use a lot in this course. So if I rearrange that, right, and then solve for d, which is what I'm trying to do here, my displacement is going to be the x squared plus y squared, and then all that's going to be square rooted, which ends up being 7.5 squared plus the 45 squared. Again, don't forget that radical. If you get one of these calculations wrong, it's probably going to be because you forgot to write a little square or you forgot to write the radical. So when we actually solve for this, right, square each of those values, add them together, then get the square root, right, which is going to be 56 meters squared plus 20 meters squared. Then that's 2080 meters squared, which ends up being 45.6. I'm getting off the paper. 45.6 meters. Now, this is just the magnitude. Okay, this is just the magnitude. I am being asked to solve for a displacement, so I need a direction. Now, we are going to use theta to represent that angle, and theta is equal to the inverse tangent of your delta x value divided by your delta y value, which is to say, inverse tangent comes out to be a little off the screen there again, sorry. Now let's talk about this type of language here. Like, yes, the calculator is going to tell me the 9.5, absolutely, right? But what you want to understand, what you want to do to interpret this triangle is that we're measuring this angle right here. And this angle, starting from north, is moving to the east 9.5 degrees. Okay, 9.5 degrees. Now, do you remember when you guys studied complementary angles in math class? What's the complementary angle to 9.5? Here we go 90 degrees minus that, right? Now, because there's another angle here. This one. That wouldn't be 9.5, that would be 80.5. But we wouldn't say east of north, we would say north of east. right? So this word that follows of, that's where you start. And then you move this direction this far. Right? So from my first one that I actually used to do my calculation, here's my angle. I start at north, right? Y-axis. And then I move this direction, east, 9.5 degrees. I could also report this angle as my direction and be just as accurate. But I would have to say 80.5 degrees north of east. Fair enough? You're starting east and then moving north 80.5 degrees. Either of those are correct. Okay, but you have to be consistent with your own designation right there. That's the trick. That's the trick. So again, Pythagorean theorem for the magnitude, and then inverse tangent for your direction.